放 YouTube 这样子哈。那当然我知道这个我重复了 N 这么多次啊，就是说我没有说这个简单哈，就是说那我们试试看。当然就是说如果有问题的话，可以课后或者是怎么样，或者是那个我到那个解释的部分的时候，就是请我就再解释一次哈，这个是可以的 ，OK 吗？那OK， I think okay good. I think we stopped last Thursday at this point. How to draw 3D graphs on a 2D plane. 3D graphs on 2D plane. So the first way is the first method is we call isometric. This is in engineering we call this projection. This is the Chinese term of saying this, projection. You will see this in next semester. So the first way is isometric projection, and I explain how to do this. We have 120 degrees here, 120 degrees here, and 120 degrees here. And we put X, Y, and Z axis. If we have one that with one axis and we have three, then 2 or 3, then this if we have more than one, then we use this word, right? So this is the isometric projection of a elongated cube. So the next way to draw 3D graphs on a 2D plane is called oblique projection. So we begin by drawing XY axis in the same way as in 2D. Is that okay? We begin by drawing the X and Y axis as in 2D problems. It's okay. And then for the z-axis, we draw it like 135 degrees. This is 90 plus 45, right? 90 plus 45, 135 degrees here to the z direction. Towards the bottom left-hand side. So the angle between X and Z axis is 135 degrees, and between Y and Z is also 135 degrees. XY 轴的一块纸板这样子，你可以帮我拿下来。我办公室。Is that okay? So in this method, of course, we can draw X and Y axis in the same scale. That's 1, 2, 3, and 1, 2, and 3. But for z-axis, we cannot do the same. So this is you can try drawing like this, but we don't scale. So for the same prism, for the same column, or for the same shape on the left hand side, how can we draw it on the right hand side? So we have our x-axis is 1 unit, and the length in y-axis is 2 units. So we have like this, right? And then we have in z-axis we have how long? 1 unit. So we have like this. Of course, if we remove hidden lines, it is like sorry. It is like this. Is that okay? I'll give you time. Okay. Of course, you will learn how to draw nice drawings in your next semester's drawing course. So these things are originally in the drawing course. Okay, thank you. Okay. So if you are writing your homework, doing your homework in the future involving 3D drawing, so you can use either the left hand side one or the right hand side one to draw your figures. Let's check it out for the problems we meet in the notes. So I'll give you a bit more time. So I'm not sure about because some of you are using your tablets, and I assume for some programs, if you draw a line not very strict, if you hold it on that, I think it will turn into a straight line. So you can try doing that. So is I assume of you okay. Next one is we want to go back to the top of the page. You want to go to the top of the page. And this is anybody wants me to give more time to draw these two? Okay, I assume most of you are all right. So we go to unit vectors in 3D. So what is unit vectors in Chinese? Or what are unit vectors? What is unit vectors in Chinese? Okay, so the length of those unit vectors is 1. So in 3D problems, we have of course we have unit vectors in 3 directions. But before we go on, let's have a discussion on some relationships. If we have a force let's begin with let's begin with 2D. We have a force here, and I think last Thursday we talked about this angle theta, right? Because because this force F links, because this theta, angle theta, is connects F with x-axis. Let's mark it theta x. Let's mark it theta x. Of course, for using the same logic, using the same logic. Using the same by using the same logic, we can draw another angle which is called theta y. Does it sound reasonable? So is it okay for you? Because this theta connects F with x-axis, so we mark this theta x. So using the same logic, we connect this force F with y-axis. We call it theta y. So let's make a definition. Theta x is the angle between F and positive x-axis. Positive is I will use this in the future. Okay. Theta x is the angle between F and the positive x-axis. So theta y is the same. That's the angle between F and the positive y-axis. Oh, I should write it more clearly. So if we have 3D, of course we can define a theta z. Yeah, take your time to write it down. Of course, if you can't, if you have difficulty following during the class, I have YouTube video afterwards. Thank you. Okay, and in 2D, so are you okay with this? If we are okay with the definitions, let's have a look. In 2D problems, theta x plus theta y equals to how much? You can also say it in Chinese. Theta x plus theta y is always equal to 9 degrees. Very good. Very good. In 2D. I have a sample here. You can take a look after you can take a look afterwards during the break or after in the next hour. So in 2D prop, this is our vector f. This is our vector f, and we have x-axis and y-axis, and this is theta x and this is theta y. We always in 2D problems, if this vector f is on the xy plane, xy plane, that's theta x plus theta y is always equal to 90 degrees. But if we have a 3D force, the force is going out. Z-axis is this way, right? X, Y, and Z. So, and if we have a Z-axis, you can see that because these two, I draw it like this, that these two are equal to 90 degrees. But if the force is going out in the Z-axis into the 3D space, you can see theta x plus theta y, because in a 3D space, theta x is from here to here. So it is larger than 90 degrees. Is that okay? Oh. So in 3D space, theta x plus theta y is larger than 90 degrees. Okay, so you can have a, it's a bit wet here, but and you can have a look and give it back to me after the class is okay. Greater or equal to 90 degrees. Here. Is that okay for you? So we have a more complicated problem here. So how should we go on from here? So anybody want to, I will give you time to copy this down. Our friends in room 105, okay. No. What's the time now? Is that okay? So if all of you are okay, then I will go on. So we have a let us draw it again. Draw a 3D space again. X, Y, and Z. Suppose if we have a force in the 3D space, like that piece of paper, that we have a force going out. Let me draw it longer. It's always good to draw bigger figures in your homework, test, or examination. It's always better to draw larger diagrams. Bigger diagrams is better. Let's see. We have so we can always draw these, and because it is in 3D space, we can have we can write vector f is equal to fxi plus fyj plus fzk, and this is equation 2.20 on page 55. Of course, and then these are the unit vectors. Because it's in 3D space, we cannot. We need this one because k is the unit vector in z-axis in 3D space. Of course, in the take some time to draw it. So we come to the next part. As long as I see pens writing, I will wait. So take your time. Okay. So I will. So if we, of course, in the I think last week or the week before last week, we discussed this fx equal to f cosine theta x, and fy equal to f cosine theta y, and fz equals to f cosine theta z. And these three are shown in figure in equation 2.19 on the textbook. The next thing is, how do we draw these three on here? How do we draw these three quantities, these three magnitudes on this figure? Let's try. So we know cosine theta, we know theta x is the angle between f and the positive x-axis. So we have this is theta x. So what is cos f times cosine theta x? It means we have this. If we have a right angle triangle here, and this part is fx, right? Is that okay to you? By the same logic, if this one is theta y, and we can draw a line perpendicular to the y-axis. Then this is a right angled triangle. And this part is equal to fy equals to f cosine theta y. You can do the same on fc. it means for the same because we had this and we also have this. It is shown graphically. It's shown in the figure like this one. So let's put these three into this equation. This is you can first write it down. F is, after you write it down, you can think about it, that F is the magnitude. And because in each factor, we have magnitude and we have direction. So we have the magnitude F here. Where is the where in this equation do we know the direction of the vector? So in this vector, the magnitude is F, right? And these three are the unit vectors. Therefore, these three quantities will give us the direction of the vector. These three, cosine theta x, cosine theta y, and cosine theta z. These three will give us the direction of the vector. Therefore, these three are called direction cosines collectively. Is it okay? So let me stop the recording first and give me a couple of minutes before I give you a break.